okie dokes, we want to find and classify all stationary points and then do a sketch. Okay, so remember, for a stationary point, we need to find that, or we will find that when we make the derivative equal to 0. So if we look at part A, let's kick off with that one. We've got f of x equals x squared take 2, so therefore f dashed of x is 2x, and clearly the only time that that's going to equal 0 will be when x is 0. If you get into a routine about how we write these, it just becomes second nature. So we get 0, and of course when you pick a number beyond 0, bigger than 0, so 10, 2 times 10 is positive, and when it's a negative value, 2 times negative value is clearly negative. So what we've got happening here is we are decreasing and then increasing. So clearly we have a local minimum when x is 0. Okay, so when x is 0, how are we going to find our y value? Well, we have to pop it back into our original equation. 0 squared is 0, take 2, so we get 0 minus 2. Now, I did say that we have to sketch this. I'm going to cheat a little bit for the first one. Right, the reason I'm cheating is because we thought we should already know what that function looks like. Okay, x squared, we know that it's the basic parabola, and then the minus 2 drops it down by 2 spots. So on our calculator, already popped that in. Yep, no surprises, and you can see absolutely we have got a local minimum, and if I g-solve min, correct, we are spot on. So let's not sketch that one in this case. Hopefully that makes sense. Okay, onward to number or value letter C. Okay, I will now write the function since it's a little bit far away. X cubed minus 3x plus 2. Okay, to find our stationary points, we first need to find the derivative. So 3x squared minus 3, we are solving for when the derivative equals 0. And I can already see that there's a common factor there, so I'm going to pull that common factor out. I'm left with x squared take 1. Our sensational factorising skills means we recognise that to be difference of 2 squares. So x take 1, x plus 1. And therefore, what makes this equal to 0? 1 and minus 1. Okay, so now let's do our sign diagram. You should be working down the page, but I just want to keep everything so we can see it. And just a point now to remind you that to put on our sign diagrams, we put any asymptotes, and when the function, the derivative equals 0. In this case, we have no asymptotes because we're not dividing by anything, no x's. Okay, so here we go. Let's pick a value beyond 1. I'm going to go 10, so 10 plus 1 is positive, 10 take 1 is positive, and so on. Okay, so hopefully by now we're happy with how we can suss our values inside. A number between 1 and 0, 1 and minus 1 is 0. 0 plus 1 is positive, 0 take 1 is negative. A negative times a positive is a negative, and then we're timesing by positive 3, so yes. I'm pretty confident now that it's plus minus positive because there's no perfect square. Normally around a perfect square you will have the same sign, so it might be plus plus minus minus, and that's where we have a stationary point of inflection. Okay, so what this means now is we have a increasing and then decreasing, and then we've got decreasing and then increasing. So we have a local max. Okay, so we've got a local max at minus 1 something, and we have a local min at 1 something. So how do we get the y value? Well, we pop it back into this expression here. So minus 1 cubed is minus 1 plus 3 plus 2, so that means that's going to be 4. And then when x is positive 1, we get 1 cubed is 1, take 3 plus 2, so that's going to equal 0. All right, now it's time to sketch. Okay, axes miraculously appeared. You need to make sure that you draw them with a ruler, please. Okay, so 1, 0, so here we've got over here, we'll just exaggerate a little bit, 1, 0, we've got a minimum, so it's sort of going to go like that. And then at minus 1, 4, we've got a maximum. Okay, so it's sort of going to go like that. A couple of things we know is that we also have a y-intercept of 2. Now, I tend to put that in later. It's not asking us for the x-intercepts. Okay, so I'm just going to draw a rough sketch. It doesn't have to be to scale. Oops, not that great. All right, there we go. I will add in my y-intercept of 2. If I wanted to find this x-intercept, then I could use my calculator. Okay, I could either graph it or I could go to polynomial solver. So let's look at one that we prepared earlier. Whoop. And that's got the general shape. Obviously this is skinnier because the scale is different. So if I want to find and add a little bit more information to my graph, so we have that that is actually minus 2. Probably would have been best to do that first. All right, so we'll stop that one there and I'll do the next ones in the next section, next video.